In this set of notes, we're going to learn a new way to graph a line using slope-intercept form. We're going to use the y-intercept and the slope in order to graph the line quickly without having to make a table. The first thing we want to know is what slope-intercept form is, which is when y is isolated, and we write it as y equals mx plus b. In this case, the slope is always going to be our coefficient of x, so it's always multiplying x. I'm going to abbreviate that. And the y-intercept is always going to be that number that's being added or subtracted on the end. So if it's being added, that means the y-intercept is positive, and if it's being subtracted, that means the y-intercept is going to be negative. It's also possible that this could be written just in a different order, where the y-intercept comes first and then plus mx. We'll see if we see an example in one of these in a second. But it's just important to remember that the slope is always the x multiplier. Once we identify these two items, then we're going to be able to use them to graph. So the first thing we're going to do is just practice identifying the slope and the y-intercept. Let's look at example 1. So in example 1, since y is already isolated, that means it's in slope-intercept form, which means my slope is just going to be my coefficient of x, which in this case is 3. And my y-intercept, you can actually write the y-intercept two ways. One is you can write it as an ordered pair, so in this case it would be 0, 4, which means the b value is just 4. So the y-intercept itself is a point, and the b value, they use the letter b, not really sure why, but that's going to be 4. One way I think about it is m for multiplier, b for begin, because when we graph using slope-intercept form, we're going to begin at the b value. On example 2, y is not isolated yet, so I can't yet identify the slope and the y-intercept. So the first thing I'm going to do is get y by itself, and I'll do that by subtracting 3x from both sides. Now this is what I was talking about earlier, where the slope is still going to be my x multiplier. So in this case, my slope is going to be negative 3. My y-intercept, I could write as the point 0, 2, and the b value would just be 2. Let's look at example 5, and then I'll have you do the other 3 on your own. So on example 5, my first step is to get y by itself. So first I'm going to subtract x from both sides. And then I still have to divide by 4. So in my first bean, I've got 6 over 4, which is going to reduce to 3 over 2. And then minus, remember there's really a 1 there. So in my second bean, I have negative 1/4 x. So then here my slope is my coefficient of x, which is going to be the negative 1/4. My y-intercept would be 0, 3/2, and my b value would just be 3 over 2. So it is possible to have a fraction b value. Now if I was going to graph that, I might actually make it a mixed number. It might be a little easier to see. So at this point, you're going to pause the video. You're going to try examples 3, 4, and 6. Press play when you're ready to check your answers. So on example 3, y is already isolated, so my slope is 5. My y-intercept is the point 0, negative 3, which means my b value is negative 3. On example 4, to get y by itself, I subtracted 3x from both sides, then divided by negative 3. 12 divided by negative 3 was negative 4. Negative 3x divided by negative 3 was positive 1x. My slope is 1, and my y-intercept is the point 0, negative 4, with a b value of negative 4. And on example 6, to get y by itself, I subtracted x from both sides, then divided by 3. 9 divided by 3 was 3. And then remember there's really a 1 here, so this becomes minus 1/3 x. Slope of negative 1/3, y-intercept of 0, 3, and a b value of 3. So now that we've practiced identifying the slope and the y-intercept, we're going to use it to graph our lines. So it's really important that first the equation is in slope-intercept form. So if that's kind of like a pre-step, you want to make sure that y is isolated. Otherwise, it's not in slope-intercept form, so we can't use it yet. And then we're going to start at the y-intercept, or the b value, and think b for begin. Then from there, we're going to use our slope. But remember, slope is really rise and run. So from our b value, we're going to rise and run according to the slope, and it's really important that we pay attention to the sign, whether it's positive or negative. Then we're going to plot multiple points in both directions. and then we're going to connect with a ruler or a straight edge. So on example 7, I noticed that first y is already isolated. It's in slope-intercept form. So I've got my slope of 2/3, and I've got my y-intercept of -1. So I'm going to begin at the b value of -1. Remember, a y-intercept is the place where it crosses the y-axis. So this line, which I don't even see yet, I know is going to cross the y-axis at -1. Then I've got my slope, which is 2/3, and it's already a fraction, which is nice. If it wasn't, I could make it one. And so that means I'm going to rise 2 and run 3. And I'm going to do that from my y-intercept. So if I rise 2, run 3, and then I put a point, and then I'm going to do that again. So I'm going to rise 2, 1, 2, run 3, and I'm going to put a point there. And now I'm going to go backwards in this direction as well. So I'm going to do the exact opposite of what I just did. So instead of going up and right, I'm going to go down and to the left. And you can see how that point lands still on that same line. And I'm going to connect this with a straight edge. Unfortunately, the app I'm on doesn't allow me to use a straight line. And the last thing I just want to double check is, as I read this line left to right, it's going uphill, which makes sense because my slope was positive. Let's look at example 8. So on example 8, again, y is already isolated, so I'm ready to graph using the slope, which is -2, and my y-intercept, which is 5. So I'm going to start by going to 5 on the y-axis, because that's my y-intercept. Now this time with my slope, -2, I don't have a rise and a run yet, but I can put -2 without changing it. I can put it over 1 to make it into a fraction. So that means my rise is -2, my run is 1. So from my y-intercept, I'm going to rise -2, which means I'm going to go down 2, and I'm still going to run 1. That 1 that I drew is a positive 1. So I'm going to go down 2 over 1. And what I notice as I'm doing this is it also makes sense because my line as I'm going left to right is going downward. And then I've got a little room if I go back to the top, I'm going to go in this direction. And so instead of going down and right, I'm going to go up and to the left. And I just want to do it as many of those points as I can fit. And then at this point I would take out a ruler or a straight edge, and I would connect, and I would put arrows on both ends to show that that line could extend forever in both directions. So at this point I want you to pause the video and try examples 9 and 10. Graph your lines, make sure you're putting multiple points in both directions, and connect with a ruler. Press play when you're ready to check your answers. So on example 9, it was already in slope-intercept form. I started at my b value of 2, and I hear this negative. It's easiest if I just assign it with the rise, so rising -3 and then running 5. And so I went down 3 over 5. And that's the only point that would fit in this direction, and so then I went up 3 and left 5. And the key again here is just reading this line left to right and seeing that it has a negative slope, which it did. It was a negative slope. On the next one, I started at my b value of -2, and on this one, since my slope was not a fraction, I could make it into 1 by making it 3 over 1. And so then I rose 3, ran 1, rose 3, ran 1, and then I came and did it in the opposite direction as well. And as I read this line from left to right, it's going upward, which means it has a positive slope, which matches what I see in my equation. Let's do example 11 together, and then I'll have you try the rest on your own. So on example 11, the first thing that I see is that it is not in slope-intercept form. Y is not isolated, and so my first step to getting it into slope-intercept form would be to subtract x from both sides. And then I'm going to divide by 2, and so in this case I get 2 minus 1/2 x. And so now my slope is -1/2, and my b value is 2. And so I'm going to start at 2 on the y-axis, and then I'm going to rise, I'm going to go down 1 and run 2. So again, when I look at that negative sign, I just attach it with the top. I think that's a little bit easier. So down 1, right 2. And as I'm doing this, the fact that my line is going down 1 from left to right means that it has a negative slope, which matches my equation. And then I went back and I did some in the other direction as well. And so all my points should fall in that same line. The most important thing you can do when graphing using slope-intercept form is just really making sure that the slope type, whether it's positive or negative, matches the equation. So at this point, you are going to pause the video. You're going to try examples 11, 12. Oops, they're clearly out of order, but here, so you're going to do this 2 examples right here, then this. Oh, they're all 11 and 12. Look at that. So you're going to do all these 11s and 12s. Pause the video, press play when you're ready to check your answers. Remember to make sure to get y isolated first. So here, to get y isolated, you subtract 2x from both sides. Our slope is -2, and our y-intercept is 3. So I started it up 3, and then down 2 over 1, down 2 over 1. My line has a negative slope. The next one, y was already isolated, so we started our b value of -3, rise 5, run 1, positive slope. On the next example, to get y isolated, we had to first subtract 3x from both sides, and then divide by -3, so y equaled 3 plus 1x. Started at 3 on the y-axis, and then a slope of 1 would mean to rise 1 and run 1, so up 1 over 1, and then we have a positive slope. Then on the next one, to get y isolated, we start by subtracting 5x from both sides, then dividing by -2, so y equals -2 plus 5 over 2x. Start at -2 on the y-axis, and then rise 5, run 2, and did that in both directions. As I read my line, it has a positive slope. And then on the last one, y is not isolated because it has the negative sign in front of it, so we're going to divide both sides by -1. That's just going to change the sign of everything on the right side, starting at -3 on the y-axis, and then down 4 over 1, and then did that in the opposite direction as well. And as I read my line from left to right, it has a negative slope.